Hello, today we'll be talking about hemostasis. Hemostasis, if we were to dumb it down and make it pretty simple, hemo means blood, stasis means stop, blood stoppage. It's a localized blood stoppage though, so make sure we identify that it's a localized blood stoppage. Throughout the day we go through multiple amounts of micro tears, from bumping into things, from touching yourself to slapping yourself, not touching yourself, I shouldn't say it like that, sounds weird. From maybe just getting, a slap on the arm from somebody, we go through multiple amounts of micro tears. Plus the tissues, whenever they're damaged, and there's any kind of tissue damage within the blood vessel, the intact integrity or the endothelial surface is disrupted from its normal healthy lining, that can cause hemostasis, a blood clot to form. What we're going to do is we're going to go through hemostasis. Okay, hemostasis. Now, hemostasis, we've already verified, means blood stoppage. It's a fast, localized event, but it occurs in three phases. There's three parts. So let's make a triangle. Okay, a triangle. Each end is a part of the hemostasis. Sometimes it's easier to just make it simple. Hemostasis. Hemostasis means blood stoppage. It's a fast, localized event that occurs within 1, 2, 3 stages. What's the first stage? Vascular spasm. Vascular spasm. We're going to go into great detail about vascular spasm and the different mechanisms that trigger this. This is the first event that occurs. So I'm going to number them also in the order that they occur in hemostasis. First one is vascular spasm. It's the first occurrence to injury or a ruptured blood vessel in which the actual smooth muscle, we'll talk about it here in a little bit. We'll get into detail. Let's not rush ourselves. The second thing that occurs within the localized blood stoppage, a fast stopping of the actual torn blood vessel, which includes vascular spasm, and the second one that occurs is platelet plug formation. Okay, we're going to go into this. Platelet plug formation. So hemostasis is a fast, localized blood stoppage. Okay, it occurs within 3 phases. One is vascular spasm, second one is platelet plug formation, and the third one, like I said, we're going to go into great detail about these, so hang in there. And the third and possibly the most complex one, which I'm going to try to make it as simple as possible, is coagulation. So we're going to have to go over the coagulation cascade. What factors activates this factor activates this factor. We're going to dumb it down to the most simplest thing that we need to. Okay, so if we were to characterize hemostasis, hemostasis is a fast, localized event in stopping bleeding. Okay, it's a blood stoppage. It's a fast, localized event that occurs in 3 phases: vascular spasm, platelet plug formation, coagulation, in that order. Okay, that is hemostasis. Now what we got to do is we really have to understand these 3 individual steps. Okay, these 3 individual steps. So let's make this simple as possible. Let's just make let's make this like a story. Sometimes things are easier to understand and remember when it's in a story. Okay, so let's just make a large blood vessel here. Okay. Here's one end, and here is another end. Okay, there's that edge. Endothelial cells, you know that. Those taking anatomy and physiology, you should know that the innermost layer of a blood vessel is known as the tunica interna, or tunica intima, because it's intimate with the blood, or it's just the most internal layer. It actually comes in direct contact with the blood. Actually gains most of its nourishment from obtaining some of the nutrients within the blood and the lumen. And it's actually just going to be endothelial cells, white endothelium, continuation of the endocardial layer within the heart, minimizes friction to provide a slick and slippery surface. But basically, we're going to talk, this is the nucleus, because endothelial cells have nuclei. They have nuclei where DNA is housed in order to produce proteins, which we're going to talk about 2 of those proteins that are very, very important, and one in vascular spasm, one in platelet formation, and then some of them in actual coagulation, and fibrinolysis as well. Alright, well anyway, let's get focused now. Okay, this is a blood vessel. Okay? Now, healthy endothelial cells, they should be smooth. Okay? That's one thing. Healthy endothelial cells should be smooth. Okay, so before we start understanding what happened, before what happens in hemostasis, we have to understand first what's normal. What's normal. That way, when we understand what's normal, what goes wrong is what causes hemostasis. Because sometimes not only can hemostasis occur from tissue damage, it can occur because of something. One of them is that the endothelial cells might not be smooth. For example, you know that there's cholesterol called LDL, low density lipoproteins, and the low density lipoproteins deposit the actual adipose tissue and the actual phospholipids and triglycerides into the peripheral tissues. Well, sometimes that can develop, and it can actually cause plaques, fatty lipid deposits or plaques to develop within the walls of the arteries. Not only can that cause hemostasis to occur, blood clots, but it can also protrude into the lumen, and by protruding into the lumen, that causes the blood flow. The volume of blood passing through this region to undergo lots of peripheral resistance, and so that increases blood pressure. But anyway, we got disfocused there. One of the things is smooth endothelial cells. Second thing is they produce, and this is possibly the most important one, they produce, to inhibit, normal healthy endothelial cells produce 3 chemicals that keep, let's say it like that, keep platelets inactive. That's a good way to say it. Produce 3 chemicals that keep platelets inactive. Those are the 2 main things: smooth, intact integrity of the endothelial cells, and 3 chemicals that keep platelets inactive. Now, by now, if you have understood blood and its components, you take a hematocrit, you take someone's blood, you put it into a hematocrit, apply a centrifugal force to it, separates the actual blood into 3 layers. Buffy coat, which is consisting of the white blood cells and platelets. That's right in between the erythrocyte, which is the more, the 45% is actually going to consist of the red blood cells, and then the plasma layer, which is 55%. And maybe in future videos I'll do blood and its components. But right in between, smushed in between the erythrocyte layer and the plasma layer is the Buffy coat. And in the Buffy coat, which makes up less than 1% of the actual hematocrit, is going to be consisting of white blood cells and platelets. You know that white blood cells are about 4,800 to 10,800 white blood cells within every millimeter cubed of blood. You can find that many white blood cells. And platelets are about 150 to 400,000. You can find them per millimeter cubed of blood. Well, platelets are circulating through our blood plasma. They're circulating through our blood plasma. Let's draw a little platelet here. Here's a platelet. Platelets, they don't have nuclei, because platelets are just tiny little cytoplasmic cell fragments. Platelets are just tiny little cytoplasmic cell fragments. They were formed from there was what's called a pluripotent stem cell, or a hematopoietic pluripotent stem cell, or we can call it a hemocytoblast. And he undergoes a differentiation, becomes a lymphoid stem cell or a myeloid stem cell, and then that myeloid stem cell can become what's called a megakaryoblast, and then a promegakaryocyte, and then a megakaryocyte. And then what happens is there's little capillaries in the actual red bone marrow. They're called sinusoidal capillaries, and it's one of the 3 capillaries that we have, and it gets stuck within these sinusoidal capillaries and it blasts into tiny little cytoplasmic cell fragments, which we call platelets. So they're not nucleated. They're not nucleated. But platelets, they're sleepy. They're sleepy when, whenever the endothelial cells are active. They're sleeping. Sleeping, sleeping. It's very educated as well. Very educated individual that has hair, glasses. It's looking weird, but these platelets, are kept inactivated by three chemicals that are produced by healthy endothelial cells. Smooth, intact integrity of the endothelial cells. One of them, out of the three, is nitric oxide. Not nitrous, nitric oxide. Nitric oxide binds onto the receptors of the platelets and inhibits the actual platelet from adhering to the endothelial cells. Another one, remember, one of them is nitric oxide. The second one is called PGI2. PGI2, which is prostacyclin. Prostaglandins, it's a derivative from prostaglandins, you know. Some of you who know a little bit of your endocrinology, you know that there is what's called arachidonic acid, and that arachidonic acid gets broken down into different kinds of derivatives of prostaglandin. And one of them is PGI2. We'll learn another derivative later, and that's called thromboxane A2. But PGI2 also binds on to the receptors of the platelets and inhibits the receptors. This receptor is also pretty sad because he doesn't get to adhere to the endothelial cells. So, nitric oxide, prostacyclin, and another one. Most books will say, and most books will not put this in it. Adenosine diphosphatase. And some of you might read in your book and you might not see that. Some books do, some books don't. The reason why you need adenosine diphosphatase is whenever the platelets start aggregating towards the damaged endothelial cells, it releases a chemical called adenosine diphosphate. And by breaking down the actual phosphate groups, that would hinder this platelet from actually causing him to adhere. Okay, so nitric oxide, prostacyclin, adenosine diphosphatase inhibits the platelet from adhering and aggregating towards the actual endothelial cell surface. So that's what inhibits him. So we have hemostasis. It's actually going to be a fast localized event. It's stopping the blood. It occurs in it's stopping bleeding, I should say. So it's localized blood stoppage, fast localized event, occurs in 3 phases. First one is vascular spasm, platelet plug formation, coagulation. Okay, normal healthy endothelial cells. What determines that? Smooth, intact integrity, releasing antithrombotic substances that keep the platelets inactivated, like nitric oxide, prostacyclin, adenosine diphosphatase. That keeps the platelets inactive within the bloodstream. Now, what happens if this platelet gets hurt? I'm sorry, what happens if these endothelial cells undergo damage? Now, you have to understand something. Platelets, all they think about is collagen. That's all they think about. They are collagen lovers. All they think about is collagen. I love collagen. That's all they think about. All platelets can dream about is collagen. They want to adhere. They don't dream about it. You know what I'm saying. Just trying to make this interesting. They dream about collagen. Now, what's so important about collagen? You know that the tunica interna, right underneath the tunica interna, all right, exterior to it, okay, is going to be what's called a subendothelial layer. A subendothelial layer. And it's actually going to be composed of a loose connective tissue. Now, loose connective tissues could be like areolar connective tissue, adipose connective tissue. So, most likely this is areolar connective tissue. And what's an areolar connective tissue? Different kinds of collagen fibers, reticular fibers, elastic fibers, collagen fibers. So within this is going to be collagen. It just provides support, you know. It acts like a basement membrane to the endothelial cells to provide force for them to exert up against whenever blood pressure is fluctuating, okay? But what happens is when this platelet sees the actual collagen fibers, he wants to start adhering to it. So what are we going to do? Let's say I damage these 2 endothelial cells. I slice a person. I don't know, you know, it's kind of gruesome, but I did. Let's say I did that. Let's say sliced a piece of that out. Now blood's pouring out of that region. Sounds kind of sick when you think about what I'm saying. You know, blood starts pouring out of this region. Do you think that healthy endothelial cells, smooth, intact endothelial cells, will be able to release prostacyclin, nitric oxide, adenosine diphosphatase, which will inhibit the platelet from actually adhering to his love, collagen fibers? No stinking way he won't. He won't be able to release prostacyclin. he won't be able to release nitric oxide. He won't be able to release adenosine diphosphatase. And now the endothelial cells are no longer intact. They're not smooth. In this drawing, I drew them pretty wickedly. It looks shredded, but it's going to start adhering to the collagen fibers. Right before it does that, all this blood's starting to spill out. Do we want some of our actual blood plasma to start spilling out of the circulatory system? No. We want to retain it. What was the first event that occurs in hemostasis is what we're going to talk about right now. First one was vascular spasm. So, we said that this was the first event. The first event that occurs when a blood vessel is ruptured, injured, or damaged in any way. What is vascular spasm? Here it is. Write this down. It is the immediate vasoconstriction of the smooth muscle within that ruptured or damaged blood vessel. It is the immediate vasoconstriction of the smooth muscle, the circularly arranged smooth muscle, within the injured or damaged or ruptured blood vessel. That's what it is. Now, if that's what it is, what causes the smooth muscle to contract? 3 things. Write these 3 things down. One of the first things that can cause it, vascular spasm to occur, which is the first event within the hemostasis, okay? It's going to be the immediate vasoconstriction of the circularly arranged smooth muscle within the injured, ruptured, or damaged blood vessel wall. And the smooth muscle will contract based upon 3 things. One of the things, these endothelial cells, they're not happy.